Hi everyone, very excited to be here. Uh, as you've seen in my very detailed intro, I'm a PM at Microsoft in Azure SQL, and I'm very excited to give you some information about data replication options in Azure SQL PaaS services. So this is what we have prepared for today. We'll start at a very high level, why is data replication relevant, and then we'll go a bit into more depth in common scenarios and solutions for data replication. So the list that I will go through is in no ways the most comprehensive list of options. There are so many other scenarios, there are so many other great solutions, third-party apps, but these are some of the key replication options that I thought would be interesting to discuss for today. So we'll go to SQL Data Sync, change data capture, change tracking, active georeplication, and read scale out feature. Great, and just to give you some context for the discussion, so I'm sure the other speakers have already told you about the great offerings in Azure SQL, all the way from infrastructure as a service up to platform as a service. The context for this talk will be mostly focused on Azure SQL database replication solutions. However, some of the solutions also apply to SQL Server on-prem, on other VMs, or Azure SQL MI, but we'll be mostly focusing on Azure SQL DB, just to clarify the context for the talk. Okay, so let's get started. So very briefly, why is data replication relevant? There are so many use cases for data replication in the daily life. So if you, for instance, if you are an emergency 911 system and you want to make sure that any call you receive is automatically visible across the country to mobilize resources as needed for any patients, you would need real-time data replication. If you're a business and you sell and you want to make sure your inventory is in sync across multiple regions, actually we'll see a demo around that, you would use, again, data replication. So there are so many uses for data replication in our daily lives. But now let's go a bit into more depth into data replication. So we'll go through these key scenarios for today. So we are going to discuss some solutions for synchronizing distributed applications. And here we're going to see synchronizing data across databases that store different workloads. So you might have a production database that you want to synchronize with another database that has analytics workload. Then you might use replication for business continuity, which is essential, and this refers to the procedures that would enable your business to operate even in the face of disruptions such as data center outages, large-scale outages, and regional disasters, and so on. You might also want to use replication for scaling out read-only workloads, so to offload your read-only workloads instead of running them on the read-write replica. So this way, some read-only workloads can be isolated, and they will not affect the performance of read-write replicas. And lastly, you might want to keep data synchronized also while migrating and also after migrating. So you might say, I want my source database on-prem and my target database on Azure SQL to be synchronized during migration and after, so that they remain functional. So these are some scenarios that we are going to look into today, and now we are going to start exploring these solutions into a bit more depth. So we're going to start with SQL Data Sync. I might be biased here because I'm the PM for SQL Data Sync, so we'll also do a demo here. So SQL Data Sync at a very high level allows you to synchronize data among databases that are in Azure SQL and SQL Server on-prem or on other VMs. And the whole synchronization is around the concept of a sync group. A sync group is just a group of databases that you want to synchronize, and it consists of one hub database that has to be on Azure SQL and one or more databases that can also be on other SQL Server instances, for instance on-prem. So some properties around sync groups we'll see in the demo as well, but you would set up the sync schema, which basically specifies what are the tables that you want synchronized within a database. Then you set up sync direction, and what is really interesting about SQL Data Sync is that it allows you to do bidirectional synchronization as well, so not just one way. So more specifically, you can do sync from member to hub, hub to member, and both. Then you can set up the sync frequency, so you can set it up as little as 1 second at as large as 30 days. Here is worth mentioning, even if you set it up 1 second, this doesn't mean that the sync is real time, but it will take 1 second from when the last sync was completed, and the new sync will be triggered within a second. So that's what this means more specifically. And conflict resolving policy. So this defines what should happen when you have conflict in terms of data modification. And here you have two options. You can either say the hub wins, in which case changes in the hub will override those in the members, and then you can select member wins, in which is the opposite. Changes in the member would override those in the hub. So as you can see here, you have a hub and spoke topology for SQL Data Sync. So all the member databases only sync to the hub database. So if you want to synchronize multiple member databases that are on SQL Server on-prem, for instance, you can do that, but indirectly through the hub database, which is on Azure SQL. So more specifically, changes from the hub are downloaded to the member, and then changes from the member uploaded to the hub. It's also important to know that if you are using member databases that are on-prem, you will have to install a local sync agent. And so SQL Data Sync works through DML triggers like insert, update, deletes, which are recorded in a site table in the user's database. We'll see in the demo. And since it's trigger-based, transactional consistency is not guaranteed, but eventual consistency is guaranteed. So data sync does not cause data loss. So before going on to the demo, just some use cases specifically for sync. It allows hybrid data synchronization. So this is great if you want to, if you're considering moving to the cloud and would like to put some of your application in Azure. This is great for you. It's also great for distributed applications. We talked about it already. And lastly, for globally distributed applications. And this is helpful because in order to minimize network latency, it's best to have your data in a region close to you and make sure it's synchronized with other data. Great. So now we're going to do a demo for SQL Data Sync, in which we'll synchronize two Azure SQL databases across US and Asia. Let's see. I'll play this to make sure there are no glitches. Here you can see the hub database. It's a fruit business. We see a fruit inventory, very simple. We have some fruits and want to make sure our inventory is in sync with our Asia center, where we can see only 3 of the sales have been recorded so far. So the melon has not been recorded, and we want to make sure all data is in sync. And then we'll add some more to the inventories to bidirectional sync. So I go on the hub database and create a sync group. Here I set up the sync group name, let's say US to Asia, because we're syncing data across these regions. You have to set up, you can either choose an existing database for metadata or a new one. We recommend you do a new metadata database. It has to be in the same region as the hub database. And we'll do it as a basic pricing tier because that's enough for the purpose of this demo. And automatic sync, we want the sync to be triggered every 2 seconds. And we want hub win in case we have any conflict for data modification. Private link ensures that connection between your hub database, here you can learn more, hub database and the sync service is secure. So it's a private endpoint, a private IP address that is managed by Microsoft. It's still in public preview. So what you have to do is to do a manual approval for the private endpoint before you can move onwards. So here we're approving the private link. So this is being approved, and now the sync group should be created. And now we want to add member databases. So we have to log in on the hub database on Azure SQL. And then here you can see you can add either from on-prem or from Azure. we're going to add another Azure member, the Asia database. And I'll go to my test server in Asia. And I select, and I do bidirectional sync, which we talked about. And again, I have to log on with the credential for the server in Asia. And I use private link again for the connection between the sync service and the member database to make sure that's all secure. So I will use that private endpoint. Private link only works if your hub and members are in Azure as of now. So if you have on-prem, it won't work. And now I'm going again on the Asia test server to approve the private endpoint. I have to manually approve it once again before I can have the member added to the sync group. Okay, so now I move onwards. Now we created a sync group, added members, and now we select the data that we actually want to synchronize. So we refresh schema on the hub. Only the tables that have a primary key will be shown here. So primary key is necessary if you want to add that specific table. So in this case, I will just synchronize all the data. It's very little data for the purposes of this demo. And I'll do the same for the member database. I'll select which data I want synchronized. And as you can see, we have primary key again, which is essential. Here you can see the status, and you can also get logs on monitoring. And the sync group has been created. I'm showing you again the logs and the databases. And now let's see whether the synchronization actually happened. So the expected behavior is to see same data in Asia that we had in the US, right? Because one of the items in the inventory was missing in Asia. And I'll go again to the Asia database as well to check it out on the query editor. So as you can see, Sync adds some tables on the user's database. On the hub and the member databases, you can see those tables that have been added. And they have different sync schema and other detail about the sync operation. Now we're checking to make sure that we have synchronized data in both regions. So in Asia, it seems that we had that item that was missing initially. And I'm showing you here that is the same as in the US. So the synchronization worked, but just to make sure it's bidirectional, so not just from hub to member, but also the other way around, I will insert some value in Asia as well, and we'll check if it shows up in the US. And I'm gonna add a dragon fruit. As you might see, I made a spelling error, so this won't work, and then I'll fix it. Okay, so we added this, and then we're gonna check if it shows up in the US because we set up bidirectional sync. It takes a bit, as I previously mentioned, it takes a little, so I'll go back to it. I went back to the Asia ones, and now I'm running this again. Let's see. And this shows. So the sync has happened bidirectionally on both member and hub. Great. Let's move onwards. Oops. Just a second. So we'll move onwards to change data capture. So, okay. So change data capture allows you to record, again, DML changes in SQL Server, Azure SQL MI, and soon on Azure SQL DB. So keep an eye out on that. So as you can see on this diagram, as DML changes are made to source table, they are added to transactions log, and then you have a capture process reading from the log and adding changes to the track tables, associated change tables, and CDC functions afterwards enumerate changes from the change tables and return them in a result set, in a future result set, which you can use for other purposes afterwards. In this case, we got the data, change data from OLTP into a data warehouse. So there are some key concepts around CDC. You have the change table. So each insert update operation appears as a single row in the change table. So column values after insert and the column values before the delete. And for update, you would have one row entry to identify values before update and second row to identify column values after the update. Then you have the capture process. So as already discussed, we already discussed about it, but it's important to highlight that because the capture process extracts change data from the transaction log, there is a built-in latency between the time a change is committed to a source table and the time that you can see it in the change table, but that latency is typically small, and also the maximum number of capture instances that can be associated with a single source table is 2. And through capture instance, I mean a change table and maximum 2 query functions. And last of all objects associated with the capture instance are in the CDC schema of the enabled DB, and we'll see that in a moment. Then you have the cleanup process. So this is very important because it's responsible for enforcing the retention-based cleanup policy. So it basically it removes expired change table entries, and by default, 3 days of data are retained. And lastly, you have the CDC query functions to obtain the change information. So in order to enable CDC, you have to do that first at the database level. So you have to run this stroke procedure that I'm showing you here. And once you do that, you will create the CDC schema, and the system tables will be created. Afterwards, within that database, you also have to enable CDC at the tables level. And once you do that, you'll have the capture and the cleanup jobs created. And you also have a table to track changes on the source table. You can see that up there. So it's very important to ensure that SQL Server agent is enabled for the 2 jobs to be created, the cleanup and the capture. And also, if you want to monitor CDC, SQL Server has dynamic management views for that. Use cases specifically for CDC, very many. You can track data changes for audit purposes. You can send them to other subscribers, do analytics on change data, ETL operations, event-based programming. You can run AI models on them. There's so much you can do with CDC. Great, and now let's see change tracking. So change tracking is also similar but different from CDC because it records that in a table rows were changed, so without capturing the actual data that was changed. So after you configure change tracking on a table, any DML statement that affects rows in the table will cause change tracking information to be recorded. But while change tracking, so you can see that an operation has been done, such as update, delete, insert, and the value of the column for the primary key of that row, as you can see here. Some key concepts: you have the change tracking table. Every table with change tracking enabled, similar to CDC, but in this case, you have an internal on this table used by the change tracking functions to determine change versions and rows changed since a particular version. Then you have the change tracking query function. So these again supply the details on the changes in an easily consumed format. So you can get all kind of data on the changes. Then you have an auto cleanup policy, as we've seen before, and a change tracking current version, which is interesting because so every time a user accesses a table, you can get a version number active at that moment. And if you keep that version number safely stored somewhere, next time when you go and access the table again, you can get the net change data from that version number. So that actually is very valuable. A small comparison between change tracking and CDC. You can see one of them is synchronous and asynchronous. change tracking mail, it tells you, yes, a change has been made, while CDC also shows you historical change data. And because of that, CDC, of course, has more overhead. So when we talk about storage and performance overhead, while change tracking has less. So both of them are similar in the sense that you have to first enable them at the database level and then at the tables level, and both can be enabled on the same database without additional considerations. Again, to enable change tracking, as I was mentioning, you have to do that on the database level. As you can see here, you have the retention policy, you can configure that. And then when you enable it at the table level, column tracking basically enables your application to synchronize only those columns that were updated. So this is great because you can improve efficiency and performance. However, maintaining column tracking also adds some extra storage overhead. So this is off by default. That's why you have to specifically put it as on. And then you can see how to determine whether change tracking has been enabled, and one example of a function that would get you the version number. And now let's move onwards to active Geographication. So with active Geographication, you can create readable secondaries of Azure SQL databases on servers in the same or different regions. And this is great for business continuity, especially because it allows the application to perform quick disaster recovery of individual databases if you have outages and disasters like natural disasters, human errors, malicious acts, and so on. So it asynchronously replicates committee transactions on the primary to a secondary. So asynchronously, well, at any given point in time, the secondary might be slightly behind the primary, but the secondary is guaranteed to never have partial transactions. Up to 4 secondaries are supported in same or different regions. And again, the failover has to be manually initiated by the user, and afterwards the new primary has a different connection endpoint. Some specific scenarios in this case, you might use this for database migration. So you can use it to migrate a database from one server to another online with minimum downtime, and for application upgrade. So for instance, you can create an extra secondary as a failback copy during application upgrades, and you can also use it for load balancing read-only workloads, which we discussed about a few minutes earlier. So this is not supported on Azure SQL MI. So if you are looking for Azure SQL MI, you might want to look into auto failover groups, and that's pretty much it for active Geographication. And lastly, for the read scale out feature, let's see. So basically, this works in premium, business critical, and hyperscale. And these tiers are provisioned with one or more secondary replicas, which can be used for like load balancing read-only workloads. So for basic, standard, and general purpose, these do not include replicas, and the read scale out feature is not available in these service tiers. However, like each single database, elastic pool, and managed instance in the premium and business critical are automatically provisioned with the primary read-write replica and several secondary read-only replicas. And for hyperscale, by default, you have one secondary replica created for a new database. So you can configure the SQL connection string to direct your application to a corresponding replica. Again, to monitor, you can use dynamic management views. And if you have a long-running query causing blocking, it will automatically be terminated. And through blocking, we mean if an object modified on the primary while the query logs the same object on the read-only replica. And lastly, it's always transactionally consistent state, but at different points in time, there may be some small latency between different replicas. Great. So to bring this all together, we've been looking at some interesting scenarios, like synchronizing different workloads across regions and scaling out read-only workloads. We explored some of these solutions. Time has been very limited, so we didn't have the chance to go in depth for all of them. And this is in no means the most comprehensive list. I encourage you to do more digging into this, and please feel free to reach out with questions or feedback. And yes, this is all. Thank you.